keep this in mind as I go through my opening statement. So we have two people. This is what they're saying. I say 1,000. The other guy in the hard hat says, I say 3. Let's check the data. And then guy in the hard hat claims victory somehow. There is one little blip of data there, but here's what I want everybody to do. Imagine that aliens come to Earth. These aliens want to know how old our planet is. We can't tell them because they do not speak a language that anybody here on Earth does. So the words of the Bible would be useless scribbles to them, as would any book, any science textbook. Even our math, the way we do math would be useless to them because we draw a 2 and they don't use that symbol. So, however, these aliens could do science themselves. If they can arrive here, then they know the properties of matter, they know the laws of physics, etc. What number do we think that they would arrive at? I'm certain that they would arrive at the same number that creationists also arrive at when they study things like meteorites, many billions of years old. 4.5 billion years old is the number that I'm going with. So can anybody find a plausible case that these aliens could come up with a number like 6,000 years? I think without the Bible, you can't possibly get to a number like that. These aliens would be vastly more competent than our best scientists here on Earth. And I hope we agree that science does objectively tell us true things about the natural world. How are they going to arrive at 6,000 years? Again, it's my assertion that there's no pathway to that number. TRock's burden tonight is to justify that data, which I simply don't think can happen, but we'll see. Secular science allows the data to speak for itself. Nobody picked an age of 4.5 billion years and came up with models to force agreement with that number. There were some attempts in the 1800s, famously Lord Kelvin. He thought that by doing some math and calculating the rate or how long it would have taken Earth to cool down to its current age, he got a range like between 50 million to 200 million years. Quite a big range, and we know that that was way off as well. So those dates, though, the dates we have currently, like 4.5 billion years for planet Earth, those were assigned by taking measurements, painstakingly rigorous measurements, famously by Claire Patterson in the 40s and 50s. So in the face of this data, creationists have been doing the opposite of science. Creationists are forced to look for ways to doubt the data, to bastardize the data, or to invent non-existing concepts or dating methods to prove the date that they have picked or to disprove, in quotes, an older date. The moon's recession, the rate at which erosion takes place, these aren't dating methods, nor are they used to, the most ironic thing is these aren't even used to justify the creationist timeline. Well, if you take the rate the moon is receding from Earth, the moon would be touching the Earth 1.5 billion years ago. Therefore, the moon formed 6,000 years ago. That doesn't make any sense. That math don't math. You can and should be skeptical of individual claims. Anecdotes don't prove anything by themselves, and the plural of anecdote is not data. However, if a claim is false, then it can't be replicated or supported by tangential studies. So the science will weed out false claims. The problem for the creationist is that there are no ways to arrive at 6,000 years, and nothing in their model agrees with anything else. You get numbers that are absolutely all over the place, and most of the time, the numbers are just there to try to say the 4.5 billion year number is inconsistent or incorrect. Secular science doesn't have this problem. We already know what the underlying predictable issues or problems with claiming the age of the Earth would be. So, for example, the Earth can't be older than the universe. Well, guess what? The data agrees. The materials on Earth can't be older than the Earth itself. Well, guess what? The data agrees. Cretaceous formations, they can't be older than Jurassic formations. Guess what? The data agrees. All of these claims are scientifically confirmed. Meanwhile, none of this stuff agrees with the timeline that you would get from taking the interpretation of the Bible that creationists take. So false positives and outliers do exist. In every single data set, they exist. Those do not prove anything in the face of overwhelming evidence that all give consistent dates. Remember the cartoon picture I had before. You have to reduce yourself to flat earth arguments, flat earth style arguments of like, oh, see the oil rigs in the ocean. We can see the horizon behind them in this one picture. So therefore, the 10 million other photographs that prove otherwise don't count. If creationism is true, and science allows us to discover true facts about the universe, then there should be data that supports it. I maintain there is zero evidence data that supports 6,000 years. All creationists do is try to find ways to say nuh-uh about the secular data, but even their rebuttals don't get you to 6,000 years. Mountains of evidence is the only thing that's acceptable if you want to make a truth claim about the natural world. Not, oh, this one thing. Not, yeah, but that one study was wrong. Mountains of evidence. If you really do have a claim about the natural world is true, science will reveal mountains of evidence to support that specific claim. All of the secular data disagrees with a story written by nobody knows who, nobody knows when. The secular data also agrees with itself. So I would ask, what makes more sense to believe? And that is my opening statement. Thank you.
Thank you very much, Eric, for that opening statement. Again, a reminder to anybody in the chat, anybody just joining us as we've only just begun, please do send in your questions, your challenges. Maybe you hear something from Eric or hear something from TRock. We look like we got a pretty decent mix of positions in the chat. Send those in. I'll save them and we'll have some fun interacting with those. Okay, TRock, we are going to reset the timer and give you your opening statement. Again, it is 12 minutes. I'll start it on your first word. Oh, I see your screen being shared. Just let me know when you want that.
I'm ready now to share.
Okay. I just see our StreamYard in the back. We're good. We're good to go.
Okay. Comments were made in the comments section before the debate actually started, and Mr. Peterson pretty much reiterated the general sentiment behind that, and that is, I hear this quite frequently. We are commonly challenged to provide some testable method to demonstrate the age of the Earth. And my position has always been exactly what you see on the screen. The scientific method, using the scientific method, you can't measure time. There is no test you can do to measure time. There is no test that's going to yield a 6,000-year-old timeline, whether it's true or not. There is no test that can yield a 4.55 billion year timeline, whether that's true or not. You simply cannot measure time. It does not work that way. So what I have here is an attempt to measure time, the age of the Earth. Eric kind of alluded to this earlier. This is one of the graphs that's used to demonstrate the very ancient Earth at the, well, you can read on the screen what it says, 4.48 billion years. I did not know this until within the last few days, but that number right there actually is supposed to represent the age of the Earth. I'll show you why that is right here real quick. This is kind of a side note because it's not really what we're debating. I just wanted to point this out. That this is from gsu.edu. They use a particular trollite mineral from the Canyon Diablo meteorite. The isochron age reported by Patterson was 4.55 billion years, but that becomes 4.48 with the application of the revised decay constants for the isotopes involved. So what does that mean? Not a whole lot. Again, this isn't really the point I'm debating, but you cannot just throw 70 million years out of history because you use different math. Okay, this is perhaps, I may not exactly know what this came from in terms of whether it was a real isochron plot, but I'm calling it an idealized isochron plot. It's actually kind of annotated to help teach and understand what the isochron method is. But I have a bigger reason for showing this, because what you have here is an X and Y axes. The X is the horizontal, of course, the Y is the vertical. And basically you plot ratios for the purpose of trying to determine an age. The only things I really want you to take away from this are the data points falling across the line and the X and Y nature of the graph. So that brings me to what's called a best fit line. Over here on the left, we have a linear plot. And if you look at this, we've got several data points, and then you have a dotted line running through it. So there's a little equation right there underneath the dotted line. It says y equals 2x plus 2.2857. And then there's another number. This is called the R squared number for the best fit line. The data does not fall on the line. Not a single point in the data actually falls on that line. That's called a best fit line, and that's what isochrons are based on, a best fit line. The points don't actually fall on the line. It's not impossible that they do, but it is pretty much impossible that all of them do. So you have an R squared number that's calculated to show you what basically it's a measurement of how close collectively all the data points are to that line. Okay, that number has to be very high. It has to be well north of 90%, probably north of 95% for most people's comfort in science or statistics. But then I want to bring you over here. Polynomial and linear plots. So this is a polynomial plot. You can do this in Excel. The equation up here, the higher one up, that is the actual equation of that curvilinear graph, x squared plus 3x minus 4. Notice that the R square value is exactly 1. That's because that equation that you see there is exactly what plotted those points. That was artificially derived. That's not from any particular measured data. It's just a mathematical rendering of numbers. However, we can apply a best fit line to this, and that is this equation right here, y equals 11x minus 16. And the R square value is 0.9758, which is very high for a best fit line, even when it's matched up against a curve. But what does it imply? It implies that, well, it tells you explicitly that the data doesn't fall on that line. That's just a general trend for the data. If you follow the extrapolation of that curve, you get further and further and further and further away from that line. Whenever you're dealing with deep time, that's a really big deal. So this highlights one of the things that's missing from isochron data, is that they will give you information that looks like this. What they will not give you, there are other types of best fits. They're not all lines. You can do a best fit logarithmic. You can do a best fit exponential. You can do best fit polynomial. There are several different types of best fit. They're not all lines. In isochron data, the one thing that is ominously missing to me is that they only show you the line R square value, when in reality, a variation, a curvilinear variation, can have a higher R square value than a line can, which means it's the more statistically probable mathematical solution. So moving away from explicitly radiometric dating for a minute, the major factors and assumptions to validate are initial conditions, constant rate, and a closed system. Someone can argue that there are other assumptions involved in any type of dating scheme, and I won't necessarily disagree with that, but these are the major assumptions, and most of the other ones can generally be categorized somewhere inside these three. Okay, so let's see how radiometric dating methods stack up. Initial conditions, they're completely unknown. Nobody has any way of knowing exactly how conditions start for any particular sample that's taken. Constant rate. A lot of people don't know this, and there are some variations on opinions among young Earth creationists, but for me, I am happy to grant for the sake of argument only, that radiometric decay rates are constant over time. We will see in a minute, though, that that's not going to help. Closed system. For isochron plots, this is completely antithetical to liquid matter. Because zircons are found in molten lava, and molten lava, by definition, is allowed to move and flow and take the shape of its container, and all kinds of things can affect it, and the individual zircons can migrate around in the lava very freely. It is anything but a closed system. It's one of the most open systems there are in nature, it seems like. But for individual zircons, we can grant this to be true, but ages aren't determined by individual zircons. They're determined by a cluster of zircons. So the whole point in the isochron method is to use more than one zircon to establish a trend to help eliminate certain assumptions. But 2 out of 3, you cannot use radiometric dating to determine ages of anything. How about ice cores, VARs, and stuff like that? Initial conditions are completely unknown. The constant rate, absolutely not. You're talking about weather patterns here in both cases, and weather is anything but a constant rate. Closed system, absolutely not. Melting, erosion, etc. can erase otherwise useful information. Someone might argue that the events begin with the first lowest layer, but closed system problems apply here as well. In other words, the very beginning layers that allegedly started the sequence could be gone, and you just don't know it. How about carbon-14? It's assumed to be true, even in the young Earth model. So I freely grant the consistency of carbon-14 decay rate. Initial conditions, they're known to change over time, and they're known to change with environments and biological organisms. There are a lot of dependencies here that have to be taken into consideration. So this is not known. Closed systems, absolutely not. Biological samples are absorbent and can easily take in external contamination. And not to mention the living organism itself is an open system. So we also know that carbon-14 ratios or carbon ratios in the atmosphere affected by solar radiation, sunstorms, nuclear testing, and other events. How about tree rings? Initial conditions, yes, we grant that to be true, especially for in situ samples. Constant rate, known to be variable over time. Closed system, again, it's a biological system, understanding that weather has a direct impact on tree ring growth rates. This is not a closed system. Clocks, watches, and calendars. Now we're in the human observable realm. Designed to have a known starting point for the initial conditions. They're designed to be constant over time, referring specifically to like timekeeping devices like clocks and watches. Designed to be isolated from external influences. Does having all 3 parameters fully controlled mean that we can measure time with human-made devices? No. For mechanical devices, it must be known that no malfunction or reset has occurred. Clocks can be stopped and restarted and appear to have run constantly, when indeed the only way to know that is by observation. Initial conditions, this requires the direct observation of the starting point to validate this. Closed system must be known through observation and comparison to similar systems that no interruptions have occurred, in the same way that the constant rate has to be validated. Humans are the timekeepers of history. Documented, the initial conditions are documented by an observer. The constant rates, this is periodic documentation of related events by other observers. Closed system accuracy is controlled through public awareness, i.e. many observers. That's how we validate history, is through agreement across a broad number of people who would know about the specific history being presented. Proper keeping of time is done through human collaboration, not through counting of objects in nature and applied rates. Attempting to measure deep time by naturalistic means leads to many contradictions in physics, many unanswered questions that leave the calculations in a state of great uncertainty, and obvious signs that the Earth cannot be millions of years old, let alone billions. Some examples of these contradictions to deep time are ocean salinity and marine nickel concentrations, coastal erosion rates, dinosaur soft tissue, carbon-14 in diamonds and coal, and Earth's rapidly decaying magnetic field. I'm going to wrap this up. I know my time must be very, very near. So age limitations of available physical evidence. Ocean salinity and marine nickel concentrations limit the Earth to several million years at most. Coastal erosion rates to several million years at most. Dinosaur soft tissue to about 100,000 years at most. Carbon-14 in diamonds and coal, 80,000 years at most. And Earth's rapidly decaying magnetic field, 10,000 years at most. So I will yield my time with that.
TRock, thank you for that 12-minute opening statement. Gentlemen, that concludes our opening statements for tonight's Great Age of the Earth debate. So we're moving into cross-examination, and we got lots of time for discussion, which is good and important on a topic like this. 30 minutes each. Eric, we're going to give you the first 30 minutes to lead the way in cross-examination, and we'll start it on your first point. Go ahead.
Thank you very much. I'm going to share my screen here. Okay, so what I'm going to lead off with, this is just sort of an example on, I don't want to say how to think, but how to think about data. So TRock, you're going to get this question wrong because it's a really difficult question. It's not supposed to be a gotcha. It's just to demonstrate something. So there's a disease that affects 1 out of every 1,000 people. There's a test that is claimed to be 95% accurate. Somebody tests positive for that disease. So if you had to just ballpark, what do you think the odds that the person has the disease actually are?
Oh, TRock, I think you're on mute.
Yeah, you're on mute.
But it's from your end, so you'll have to unmute it.
Sorry.
No problem. You're good.
I don't really know, but without making assumptions, but with the information given, it appears to be 95%. Well, I say that if the test is positive and it's 95% accurate, that implies that the chances are somewhere between 95 and 99%.
That is what most people think, and that is not even remotely close to the answer. The answer is less than 2%. And I can show you why that is. These are 1,000 dots, so that is 1,000 people. Since the test has a 5% error rate, it will tell you 50 people that don't have the disease do have the disease. One person in red really does. So out of all the people that tested positive, 1 out of 51 actually has it. So the odds are only 1.96%, dramatically lower than what you would think. Now, the reason I bring that up is because if you don't understand statistical analysis, or someone you trust gave you this example and preloaded it by saying, did you know that medical researchers are all lying to you? If you trusted that person, then you'd probably have doubts in them. And the other point of this is the test actually is 95% accurate. This doesn't disprove that. It's just, this is Bayesian statistics. It's just really tricky stuff. So mainstream secular science, this is what I was talking about in my opening, it all converges and supports that the Earth is billions of years old. And there are things you can point to that look like deep inconsistencies like this one, but they don't disprove the actual rigorous data. So that was just an example. So let's go into the cross exam here. So TRock, let's say there's a kid and they claim to be 15 years old. They're 60 inches tall. However, somebody notices that they grew 3 inches over the summer. That would mean, if we do the math, that's 1 foot for a year. So at that current rate going backwards, this child reaches 0 inches tall 5 years ago. So they can't be 15 years old. They're 5 years old at most. But then the person claims, I claim this child was born yesterday. So what are the problems you can see with this line of reasoning?
Time out here for a minute. This is supposed to be a cross-examination, not a quiz.
No, this isn't a quiz. This is just open-ended
That's
question.
what you're doing. You quizzed me twice based on your own set of problems. That's not a cross-examination.
Yeah, it is. A cross-examination is just I ask you questions.
No, cross-examine means you examine me based on what I know and am claiming.
Yeah, and we're getting there.
I would appreciate some more direct questions.
Well, this is a direct question. What problems do you see with the line of reasoning here? The person saying, well, they can't be more than 5 years old, and I think they were born yesterday.
I don't even need to answer this question. It's obvious what's wrong with it.
Okay,
This
well,
has nothing to do with the age of the Earth.
it absolutely does, and I'm about to show you. So I won't read these. Just, I mean, anybody can like check it out. So there we go. These are the multiple different problems. So scientists claim the Earth is 4.5 billion years old. However, somebody notices the moon is receding. At its current rate, going backwards, the moon touches the Earth only 1.4 billion years ago. Therefore, I claim the Earth and moon are only 6,000 years old. So do you see any problems in the reasoning here, TRock?
Yes, you have some very false, incorrect information represented here.
Such as
your
what?
Your conclusion, therefore, I claim the Earth and moon are 6,000 years old, is completely inaccurate. That's not
I agree.
what we're doing here. This isn't remotely close to what we're doing here.
What are we doing?
As young Earth creationists, this is not how we present the argument or make our case.
Yes, it is. I've heard you claim that, well, the Earth-Moon system proves it can't be 4.5 billion years old. But what you're...
That's a very different thing than therefore I claim the Earth and Moon are 6,000 years old. Those
but you do claim that.
Different things.
Yes, but you do claim
I do claim that. But that therefore is not how I get there.
It's... Well, okay, that's actually my point. So you're not supporting the 6,000 year thing. And in your opening, you said we can't measure time, which is a very odd thing to say. But the problems in both examples are exactly the same. We do have ways to date things, and moon recession is not a way you date something. There are multiple ways to date, and they all agree with each other. So the conventional dating methods are accurate. And the alternative data proposed is not the gotcha that I think it is, or that people think it is. This is the cartoon that I started off with. The mainstream secular science is very consistent with billions of years old for the age of the Earth and the Moon. We point to the Earth and the Moon being less than 4.5 billion years old, as if that supports that it's 6,000 years old, but it doesn't in any way.
So are you doing another presentation or are you doing a cross-examination?
Well, I tried to do the cross-examination, but you just kind of didn't want to answer the questions, I guess it sounds like.
You've gone off in irrelevant tangents and you've made claims that I do not argue.
No, you do argue that the moon Earth system proves it can't be 4.5 billion years old.
Yes, I do argue that.
Okay, I'll go to very direct questions. What number do you think the aliens would reach and how?
They wouldn't reach any numbers because aliens don't exist. But I understand the purpose of your question. It's a thought experiment to say, okay, if some completely unbiased entity came in and tried to do what scientists try to do on Earth with the age of the Earth, they would come to the conclusion, I'll show you I'm not going to pull the slide up. I'll just tell you. They would come to the conclusion that you cannot tell the age of the Earth by counting objects on the Earth. That's the conclusion they would come to.
Why?
It is literally impossible to measure time.
No, it's not.
As soon as you start that exercise, exactly one effort has been made to actually establish a 4.55 billion year timeline for the Earth. There's only one test that does that, and that's the lead-lead isochron method. And then as soon as you say, okay, this is the age of the Earth, the first question you got to ask is, how do I know that's accurate?
So
how do you know How do you know the math I threw in a graph is accurate? I showed explicitly why this is not going to be the case, why it's not going to be accurate, because you have to plot a best fit line to data that doesn't even fall on the line and may have a curvilinear best fit, which implies that the age of the sample that you have can be very, very different than the linear best fit plot.
What makes you think that scientists didn't already think about that and can account for those types of problems you think that there are?
That's a good question. That's fair. I kind of gave a direct answer to that in my presentation as well. If you can pull the data, if you can actually pull radiometric data for the age of the Earth, like a data set. I have managed a database for 17 years straight now. I know what data looks like. If you can pull a database and show me how it is that they compared the linear best fit to the curvilinear best fit, we can have that discussion. If no such data exists, and I'm positive that it doesn't, they have not shown that yet. So there is no data to support that position.
Okay, do you consider yourself a conspiracy theorist?
No, not at all.
Do you think that secular geologists are all wrong?
Secular geologists, the ones that adhere to the 4.5
Science.
billion year timeline.
Yeah, they are right. Yeah.
Yes.
Okay, you think they're all wrong. Do you think that secular
Yes.
geneticists and biologists are all wrong?
The ones that hold to an ancient Earth of that type, yes.
Do you think that all paleontologists are wrong? Secular paleontologists are all wrong?
That hold to that age of the Earth, yes.
Do you think that secular astronomers are all wrong?
That hold to that age of the Earth, yes.
How is it that they are doing objective science, but they're all wrong? A cover-up, a conspiracy, actually makes more sense if we're assuming that their data is all wrong. I don't know how millions of people can all be doing science and just always get the wrong answer.
Okay, point number one, I don't have to resort to conspiracies to make the claim that they are all wrong about the age of the Earth. Point number two, you're kind of elephant hurdling when you say millions of scientists, because most scientists have nothing whatsoever to do with determining the age of the Earth. Most of them have nothing whatsoever to do with the origins discussion. Most scientists actually do material science. They do technology, they do modern medicine, that type of science, and they have nothing whatsoever to do with the age of the
I
Earth.
specified geologists, geneticists, paleontologists, astronomers, and biologists. And over the decades, I don't know if there's been millions of them. It's hundreds of thousands, though.
So I'll give you a more direct answer to your question. How are they all wrong? It's not through conspiracy. You can throw that completely out the window. It's because they agreed a priori to go down a naturalistic path for measuring time, and time cannot be measured. But they insist
What does that
on
mean?
doing it that way.
Do you know that we make things like atomic clocks and we track time with them? What are you
Did you watch
talking
my
about?
presentation? Did you listen?
Yeah.
The only way you can use an atomic clock accurately is if you know the starting condition, you know that it has never been interrupted and reset, and you know that it is not influenced by external forces. That's the only way it works, and it's 100% inside the scope of observation, like direct observation.
So
it's not even the same type of science or the same type of scientific method. You're literally flip-flopping like an equivocation fallacy.
No, not at all. Okay, so do you see this data here? I just started sharing my screen. TRock, do you see the data?
I do.
Okay.
Well, it's very small on my screen. Let me see.
Well, I'll explain it. I'm just asking if you can see the lines. Now, that is
I can see it better now.
Thank you. That's an extraordinarily strong trend line, right? Because this is what 90% looks like. This is what 0.999% looks like. Okay? Okay. So I get your point about we don't know the initial condition. There's too many assumptions. Okay. But what this is this is carbon-14 data matched along with sediment layers laid down and tree ring data as well. And look at how perfect the correlation is. You are right. So, like, we do make assumptions. However, if the assumptions are faulty because the things we assume aren't true, then you don't get correlations that converge very nearly to one. That kind of coincidence, you can't sell that to anybody, not to me at least. That, oh, the assumptions are faulty, but the data correlates close to one. You're not gonna. That makes no sense to try to.
Okay, back up again, because you look like you're doing it again. You look like you're making a presentation, not doing a cross-examination.
I'm presenting data, and then I will be asking you questions about the data. I have tons of questions. We'll get to them. No worries. But I have to.
Did you have a question about that particular slide?
Yeah, we're going to get to it in like literally just a second here. So also, we know, like historically, we know that there are things that happened. The eruption of Pompeii, for example. Well, guess what? Radiometric dating, we get the age that we're interested in. So we have data that demonstrates that these radiometric techniques do work. We know when Vesuvius erupted. We know when that happened. And radiometric dating agrees. So when you say things like there are too many assumptions or whatever, yeah, but we do the tests and the tests agree. So I guess my question was, how do you deal with the fact that we can use radiometric dating to date historically known events to the date that they happened?
Okay, so how do I deal with it? I deal with it by pointing out something very obvious here. You have several claims and you have single data points, which are basically the same thing as anecdotal data, but you have no data.
This is not singular.
Like
this is not singular data. This is this is a
where,
huge amount of data plotted on this graph here.
Where is the data table?
Maybe I'm stupid. I don't know what you mean by data table. So this isn't the data table.
You know, I'm not trying to insult your intelligence here. It's just that I'm really not, because I believe you are a very intelligent person. The problem here is you've got a numeric plot, and a couple things stand out to me because, like I said, I've managed database for well over a dozen years now. I know what good data looks like.
And you think that people with PhDs don't know how to plot the data correctly?
I never said any such thing. I
would
really appreciate if you would quit putting words into my mouth.
To criticize the data, you have to make that point, first of all.
No, to criticize the data, to analyze the data, I have to know how it was collected and what other supplemental data was with it. What I know about carbon-14 and tree ring dating is that carbon-14 in particular has a very piecewise calibration curve to it over time. It's calibrated to fit other methods. So one of those methods is the observable historical method. So whenever things are carbon-14 dated in, say, an archaeological dig site that you can nail down the humanly observable known date for, carbon-14 is literally has to be adjusted to it. It doesn't naturally fall on it just because it's such a perfect, accurate way of measuring time. It has to be calibrated to it a bunch. And there is, like I said, it's a piecewise function. Do you know what a piecewise function is?
Nope.
You don't?
Nope.
Well, if you don't know what a piecewise function is, you will have no objective way of analyzing data.
I look at the data from the scientists and I look at their graph and I see the correlation is very nearly 1. I understand how to look at data on a graph. If you're just going to claim that doesn't prove anything, then that's just so dishonest. I don't know what to.
I'm not questioning your ability to understand data presented on a graph. What I'm questioning is your ability to personally analyze data. What you showed, if you go back and look at that slide, what I believe I saw were years indicated across the x-axis, but at the top of the graph. Is that correct?
Yeah, thousands of years ago for the top.
Thousands, and it ranged what, something like 10 to 60,000 years or something like that?
Goes up to 50.
Goes up to 50. So you are distinctly talking about a forced match of data. Carbon-14 is very piecewise in its calibration in known history. Once you get out to 10,000 years, you're well beyond known history, even in the, and by known, I mean like some sort of archaeological reference with human activity. You're starting to get beyond known human history with that 10,000 year timeline. And all you have to do from there is to calibrate it against other methods.
What's wrong? There's nothing wrong with that.
Yes, actually there is. Go back and watch my presentation one more time. Every single method that attempts to make a date assignment suffers from at least two, if not all three, of the assumption fallacies. And you can't take three different failed methods and make a
they're not failed
method out of it.
They're not failed. And no, they're not. And we know that because, like I said earlier, if the underlying assumptions are all false, then that data can't correlate. But it correlates almost perfectly in this example. Donnie, I am sharing my screen if you want to bring it back up. I don't want to use all my time on this. So, I mean, well, I'll have to go to something else here. Yeah, if the underlying assumptions are false, then you have to claim it's the biggest coincidence imaginable that all the data correlates. And if you're just going to claim the data doesn't correlate, then I don't know. We can't have really a conversation about this.
I didn't say that. I said that carbon-14 has to be fit to some other standard.
That's done ahead of time before the study is done. And then they do the study, and then they see...
Tree ring data is part of refitting the C14 curve.
Yes, but yes, they calibrate the carbon-14 dating, but that calibration is done before they do this study. And then, because otherwise you're just saying, oh, they did it and the data didn't plot or whatever, so then they calibrate it until it works. They did not do that in this example. But I do have a question here, and it's this one highlighted right down here. So why does God's creation produce data that points to dates older than 6,000 years old?
I told you. I've already answered that question multiple times. You cannot measure time. So to claim that data points to a different age, to claim that data points to a different age than what has been observed, it's a fallacy in both science
not a fallacy.
And logic.
No scientist thinks the way you think about this. You have just magically said
that is not true.
And
that is categorically not true.
Okay, again, going back to my cartoon, no scientist thinks that. Can you find 5 that do? Probably, but that doesn't disprove the rest of it. And you've said that all of mainstream geology is wrong. All of mainstream genetics and biology is wrong. All of mainstream paleontology is wrong. All of mainstream astronomy is wrong. So, oh man, let me look for my next best. So you don't think it's possible to tell how old the Earth is?
Not through naturalistic means by counting objects and applying rates.
So is it?
I said that very, very clearly. No,
yep,
it's not possible to do.
Yep, just clarifying. So is it then your position that your claim of a young Earth is unjustified?
No.
How is it justified?
Through human observation.
When have we observed 6,000 years?
Collectively, humans have documented the history from the beginning.
Justify that claim.
That's what the Bible is for.
Justify that the Bible is true. You know that we can't watch the original words of the Bible be written, right? You don't know the initial conditions when it was being written, right?
I do know the initial conditions.
You know the initial conditions thousands of years ago when people were writing down the words of the Bible? Tell us how you know that.
Because the Bible tells us what the initial conditions are.
Instead of going in a circle, tell us how you know what the initial conditions were.
So here's where it's kind of interesting.
Reclaiming my time. Tell us how you know the initial conditions.
Because it was written what the initial conditions were. There is no other paradigm in the universe that starts at the beginning. It was written by observation, by direct observation. Here's
You're begging the question. So
no,
badly.
I'm not.
Yes, you are. How do I know that the claim is true? Because I believe that the claim is true.
Here's the irony that you're up against with your rebuttal there. The irony is that if the Earth is really ancient and anybody happened to have been able to write in your paradigm, had anybody been able to write anything whatsoever 10,000 years ago, basically your logic is that you can't believe them because you did not personally observe it and other people around you don't agree with it. That's your logic.
I don't decide what is and what is not true solely based on stories written by nobody knows who, nobody knows when. That's why we have science. Well, it's not why we have science, but luckily we have science.
That's your unobserved version. The observers say otherwise. People who actually observed it say otherwise. People who didn't observe it...
You don't even know that those things occurred. And to just say that the words of Genesis vault up to the highest standard of truth in the face of everything else is just... I don't know what you call that.
Let me show you the nature of your failed reasoning here. I'm going to ask you a rhetorical question. I'm not expecting you to answer.
You can do that during your cross-examination.
You don't answer. But I want to demonstrate your logic.
You can do that during your cross-examination because only one person does questioning during the cross-examination. So do you think that science tells us true facts about the natural world?
Sure.
If the Bible didn't exist and the Bible is true, wouldn't we be able to prove its words using science?
Again, it is impossible to measure the passage of time without observation.
So the fact that they were able to measure the radiometric decay for, I don't know if it was argon or something, and it pointed directly to Pompeii to Vesuvius when it erupted. Your take on that is it's just a coincidence?
No, that's not my take on it.
So then what's your take on it?
My take on it is exactly what I was referring to with anecdotal data. If you want real data to confirm potassium argon dating, are you guys there? You look like
we're here.
Look like you froze up there for a second. If you want real data to confirm argon dating, its accuracy, what you're going to need to do is produce a data table that shows how many, at a minimum, dozens of samples were taken from those, what were they, ash layers? They were from the ash layers, right, of the Pompeii.
There were hundreds of dots on that thing I gave you, and you said, and you nodded.
Was that wasn't Pompeii that you were graphing?
I know, but
you asked me about Pompeii.
Sure.
Stick to the subject.
Sure.
I'm telling you, my take on Pompeii and the alleged accuracy of the dating would be dependent on how much data you actually have to support it. But you don't have any data. You've got a claim about it.
No, it's data. They take. I'm assuming it's ash.
Show me the data table. I'm assuming a data table maybe does exist somewhere. Show it to me.
And you want to see how many dots are on the data table? I don't have the paper pulled up.
Of Pompeii?
What about Pompeii?
That's the one you asked me my take on.
Yeah.
You keep switching back to a different data plot.
No. Okay. I don't have the data from that study. I have the clip from it's actually a press release that they were able to do this. So if you're just going to run away from the paper and say, well, I haven't seen the data, maybe they only took one measurement. I mean, if you're just going to assume that the scientists are that lazy, then we can't do anything with that one. And we'll have to move on to the next one.
You don't have a paper and you don't have a data set. A press release is not peer-reviewed science.
The press release is revealing the study that was carried out. You are a conspiracy theorist. You just don't really. Maybe you don't know it. What else did I come up with? According to the creation model, what do you think the moon's distance from the Earth at creation was, and how long did it take for the moon to become tidally locked?
I don't have an exact number for you, but it would be on the order of probably not more than a couple hundred feet different than what it is today. And what was the other question? That's the distance answer. I can calculate. I actually do, believe it or not. I actually do have the equations in an Excel sheet where I can literally calculate what that distance was. I just don't have it open, and I'm not going to waste everybody's time going through that.
Do you do
It's
it?
going to amount.
Do you do that based on its current rate of recession and some gravitational effects?
I do it based on physics, like textbook peer-reviewed physics.
You don't think that radiometric dating is physics? You're just saying you're not doing physics when you do that?
Radiometric dating is not physics. Radiometric dating is creating an interpretation of data.
And you're interpreting the data about the moon to say it was a few hundred feet farther away. You don't know the initial conditions. You see how this is all reciprocal?
No.
Okay.
No,
The irony is lost on you. Okay.
You do not understand the difference between the two different techniques. I kind of alluded to this. I kind of basically came right out and spelled it in my presentation on radiometric dating in particular. You've got three types of assumptions that have to be made. With radiometric data, you're talking about in isochrons, like lead isochrons, you're talking about igneous rock. It was molten. It's not a closed system.
TRock, I heard you say that, and I couldn't believe you said that. The zircons are floating around in magma, therefore it's not a closed system. You're measuring the zircons. The zircons are the closed system. The fact that the zircons move around is completely irrelevant. The zircons eject lead when they form. It's a tabula rasa. So you're jumping to things like that, and it's just so that's hilarious. The way you do that.
What somebody says that does not understand physics or what's actually happening with
physicists, which you are not, disagree with you. I will go with them. Donnie, how much time do we have left?
I would say you got time for one more question if you wanted it, but we're basically there at the 30 minutes.
I yield my time. If we have time for open discussion, I can bring up other stuff. That's fine.
Yeah, maybe we'll do that after the second 30-minute discussion. If there's still things on the table to engage and interact with, we'll open it up to something more free-flowing for a bit. So, okay, guys, 30 minutes just like that. Blinked and it was over. So, okay, good fast-paced discussion so far. TRock, you now get 30 minutes to lead the way in cross-examination. I'll start the timer on your first question. Go ahead.
Okay, I apologize. I did not draft a formal list. I really didn't realize that was going to be the format until down very close to the end. But nevertheless, I'll go with it. So, question number one: when we're talking about the lunar recession that you brought up, what astrophysical events could affect the rate at which the moon recedes from the Earth within the last 6,000 years?
Within the last 6,000 years, any effect that would have occurred would be completely negligible. The things that do affect the rate at which the moon recedes from us would be, for example, the loss of angular momentum by the moon as it becomes tidally locked.
Okay, the question was specific to the 6,000 year timeline.
I answered that.
So I agree with you. Essentially nothing. Anything that may have happened is negligible. If it's gotten hit by impact meteors, for example, they weren't big enough to make a big difference anyway, right?
Yeah, but you have no grounds to claim that the moon wasn't spinning faster 6,000 years ago than it is today, for example.
Do you have a reason to think the Earth was spinning faster 6,000 years ago than it is today?
I said moon, but for the Earth, I mean, it is slowing down. We have to add leap seconds. This has been correlated with, I don't exactly know how they do this, but they're able to look at fossilized mollusk shells because they produce this like annular ring. And then there's some sort of like it deposits, there's a daily thing, and they're able to see how many deposits were done per year. But It's been a long time since I've read up on any of that.
Okay, so the purpose of the question was to establish that we do both agree that virtually nothing has seriously affected lunar recession in the past 6,000 years. We agree on that point, right?
Yeah.
And again, it's the age that's in question, so you can't refer to, you know, some quote unquote known age, because it's the method itself that we're investigating. So when we compare that,
that's what you do, though.
This is not your rebuttal time, remember? This is my deal. I'm establishing the line of questioning for you so you can answer the next question. The three assumptions I have to be validated is the initial condition, the rate, and whether it's an open or closed system. I think we are both in agreement that the rate of recession is pretty much constant based on the laws of physics. And we agree that it's, for all intent and purpose, we know it's not a closed system, but for all intent and purpose, it's not been affected by any major astronomical events, so that it can behave essentially like a closed system. Now, that's very different than a isochron dating test. An isochron dating test, one isochron, any one isochron, the isotopes that are inside of it, if you would have watched my presentation closely, we do treat that as a closed system. Those isotopes are not they're not migrating in and out of the isochron, so we're treating it as if it's a closed system for any one zircon. How many zircons are used on a typical isochron plot?
How many zircon crystals do they typically use? I don't know.
Any idea? Any rough guess?
More than one. I don't like. Why on earth are you calling the samples isochrons? That's not what an isochron is.
They're called zircons. I'm just using the term colloquially to refer to the zircons. The zircons that are used. And there is a whole rock method that actually does not.
I don't think you know what you're talking about, because calling them isochron. What is the isochron? I mean, I know it's not my turn to answer questions, so you don't have to.
Okay, then don't ask. Then don't ask questions if it's not your turn. Okay,
the isochron is the slope of the line. He has no idea what he's talking about.
Yes, I do. I use the term isochron colloquially to mean zircon. How many zircons?
If you knew what you were talking about, you wouldn't do that.
If you knew what you were talking about, you would have data, and you have none. But it's a simple question. You said you really don't know. How many zircons are used to establish an isochron plot?
More than one, because the point of of doing isochron dating is those lines converge at a point. The isochron dating method is what's used to overcome the you don't know how much parent material you started with thing.
You obviously don't know the method, or you wouldn't have said they converge. They don't converge.
Yes, they do.
They're given a best. No, they don't. They are given a best fit line, which is not the line the data actually falls on. So the answer to the original question is several at a minimum. It should actually be hundreds, if not thousands. But in practice, they typically use anywhere, I'll say, from about 6 up to maybe 20 or so, maybe sometimes more. But that's a normal range, is to have 6 to 20 zircons that you basically measure the isotopic ratios and you plot them, and then you give it a best fit line, not a convergence point. You give them a best fit line. The data does not actually fall on the line. What's the difference between that and the lunar recession method? The difference is if you have 6 or 20 zircon crystals in an igneous sample, the individual zircons can move through the liquid. This is why they have a problem called apparent isochrons, because they literally know that a migratory scenario is possible for zircons in igneous rock, and you have this conundrum called a apparent isochron, because they plot with a linear best fit line, but they know it's not the actual age of the sample.
I'm just going to jump in real quick. TRock, perhaps for the cross exam, if you could spend a little less time with the buildup and try and get more direct questions for Planet Peterson. Yeah. All right. Go ahead, guys.
Okay. So can you see can you see that the opportunities for zircons to move around in a molten liquid is a very different thing than an opportunity for a moon to be impacted, to have its recession rate impacted?
They're different things. I don't know what you could possibly think the gotcha here on this whole thing is.
It's not a gotcha. It's a, do you understand that zircon crystals have a very high melting point, higher than the igneous rock that they're found in?
Yeah.
That presents the problem of migratory zircons.
The zircon itself is a closed system. The fact that the zircon is floating around doesn't introduce lead into the zircon. I read a book on this, Geochemistry, an introduction, 2nd edition. Somehow in that 2nd edition, the physicist that wrote this book talking about zircon dating didn't update it and say, oh, by the way, yeah, this science actually doesn't work the way we thought it did. JKLOL NVM.
Are you done with your presentation?
Yeah.
Okay. Have you read the literature on fractionation?
I don't think so.
Have you read any of the literature or read any of the data tables? I actually have a data table on my computer from a radiometric database, from a national radiometric database. So the question is, have you actually seen what data is captured in these databases?
No, I'm not a conspiracy theorist. I don't read medical journals either. I don't claim vaccines don't work.
So you don't read the scientific peer-reviewed literature then?
Not very often, but I don't tell mechanics and doctors or scientists that they don't know what they're doing. And you haven't presented anything convincing to me to think that what you're saying about them being wrong is something that I should take seriously either. But anyways, what's your question?
So what would you think if you read the scientific literature and they acknowledged that the date they got from an isochron plot was not the correct date, and then they acknowledged that they need further research to establish why that might be, or they basically just summarily attributed it to some other unknown event? What would you think the integrity of the data really was concerning isochron accuracy and dating?
I wouldn't think too much about it because anecdotes aren't data. You're literally living up to the cartoon I drew earlier where everything converges around one point. Yes, it's not a perfect fit. It's the whatever you want to call it, the normal distribution is a little bit wide. And then, yeah, every now and then you get dates out there. I don't point to outliers as if to say this proves the rest of the data incorrect, but I don't have an agenda either. An alternative agenda.
What's the largest number of radiometric data points you've seen in a single table?
I saw this creationist one where they studied the age of meteorites, and it had many, many hundreds. It was in the 700 something, and I can actually get you a pretty close number for. Oh shoot, where the heck is it? I have it right here. Sorry, it'll only take me a second. Did I delete it? No, it's right here. Sorry. Average of 4.536 with the standard deviation of less than 0.1. So that's very consistent data.
You said that was from a creationist source?
Yeah, they were dating meteorites.
Okay. Interesting. Donnie, can you share my screen?
He's not here, I don't think. Or maybe he is here, I'm not sure.
You can probably hear.
Yeah,
he may have stepped away.
Yeah, maybe.
Can probably.
I can get you the name of that. Dating meteorites, since we're just kind of hanging out. Oh, awesome. Dr. Andrew Snelling, he's the guy that did it. He's got multiple studies on the meteorites, and he has hundreds and hundreds and hundreds of meteorites in his data set.
Donnie, are you sharing my screen?
Yeah, I've been sharing it, but it's kind of been lagging. Can you? Yeah, it looks like it's good now, though. Give that a shot.
Okay, is my audio still good?
It robots here and there, but it's nothing bad to the point where we can't make out what you're saying, but you do kind of lag here and there.
So, Eric, this is the largest data set I've ever been able to get my hands on. 6,123 rows of data with one header. This is from a national radiometric database. And so a few of the things that I've noted in here is that the data that would validate a mathematical model of age is not here. Number one, if you think it is, you can by all means tell me where it is, but it's not here. So my question is, where or why do you think that the people who collected this data did not see fit to include the R-square values with a minimum of 6 entries per sample age test?
I'm not a scientist nor a conspiracy theorist. I don't go around telling doctors, mechanics, scientists, professionals, working professionals, that they don't know what they're doing. I don't know where you get off.
Okay, I'll tell you where I get my information, because mathematical modeling is an engineering thing. It's what we do. It's one of the things that we do.
Yeah, and
so
if they didn't include something that
experience, I have quite a bit of experience handling data and analyzing data. And so kind of one of the things I was going to point out to you here, you see this right here? See this question behind this, but you see this column 10 geological event? That is some geologist explanation. Not captured. How many times do you think not captured or something similar to that appears in here?
I don't know, and I don't know what you mean by not captured. They don't know what.
I'm not the one that put it there. A geologist put it there.
Yeah, but what is not captured? What does that mean?
Geological event. They did not care to describe the geological event that caused this uranium lead date assignment, age in millions of years, 1.5 billion years essentially. They did not care to tell what event they thought caused that. In other words, they pulled a sample, took some measurements, gave it an age, stuck it in a database, and gave no explanation for it. Why do you think that the collective body of scientists out there collect such corrupted data like this?
So says you that it's corrupted just because they didn't capture it. They measure the, like radiometric dating. We know how to do that. You measure the parent and daughter isotopes with the isochron. You add the non-radiogenic isotopes in there as well. This thing that for some of them they have not captured. Did you search for it? Because I would like to see how many of them there are.
Well, here's one.
Notice how the uncertainty is 0.26%. Extraordinarily low uncertainty for that not captured thing. So according to them, according to the scientists that know how to do this kind of science, they have a huge degree of certainty, even though it says not captured. But TRock knows that if it's not captured, then throw it out. That's laughable.
Can you not see the utter lack of logic in what you just said? They don't even know what the event is. How can they know whether it's a 0.26% uncertainty in some event? They don't even know what it was.
You should ask a scientist.
How are you so confident that it actually means something for an event that can't even be described?
Because I'm not a conspiracy theorist that doubts all of secular science that disagrees with what I think the age of the Earth is.
That literally renders
the
this
reason
column of percent uncertainty completely useless.
That is such a flat earth thing to say. Like you point to the most microscopic thing you can, a non-expert's opinion on something, and say, throw all the data out. The ironic thing about this is you live your life exactly the way I'm describing my view on this when it comes to things that don't challenge your preconceived beliefs about how old the earth is. You go around and you trust the science. But here, because this would shatter your worldview, you have to say that it's fake.
You're conflating science with measurable, testable, and observable. This right here, can you not see that
Scientists aren't doing science?
Can you see this line right here that I have highlighted?
Yeah.
Isochron.
Yeah.
Column 10,
Yeah.
igneous crystallization.
Yep.
Do you see the difference in percent uncertainty between that one and the one that was flagged as not captured?
You have six.
There's not captured.
What did you say there were? 6,000 points of data, and we're looking at 10 of them to say, oh, that proves anything. Go ahead and sort column B alphabetically, and we'll see what chunk of those have a error percent of like less than 3% or whatever.
Column B, that's column 8.
Okay, it's really blurry. It looked like a B.
Can you see the discrepancy between what's alleged to be a known event with a factor of 50, about 50 times lower certainty on a known event than a not captured event?
11.5% is a pretty low uncertainty still. But again, with data, you have a normal distribution, and not everything lies perfectly on that median or average part, whatever we're going to call it. You don't go around saying, oh, some of the data's one standard deviation away from the mean, throw it all out. Nobody that and I barely understand statistics. Nobody that understands statistics thinks that that's what you do, that that's an honest take.
Do you see this math that I just did on this calculator?
No, because your screen looks like you microwaved your computer.
44, this line here where it says 11.46% on this rubidium strontium, 11.46% uncertainty is literally 44 times less certain than an uncaptured event. This whole database looks kind of like this. It's not valid data for telling time.
Says the non-expert that doesn't even know how to do this data. Sort that thing alphabetically. How many of the things are in that 11.5% range? I bet it's vanishingly small.
Excel wants to be very, very slow.
Well, usually if you just click on the cell.
Look at this. Look at this. There, according to this number in this title header, this much data. The event is
0%.
They basically say they have 100% on things not even reported. Not reported. Calculation type not reported.
Didn't you say there's 6,000 of them?
Correct. 6,000 what?
Didn't you say there were
6,000 entries in here?
Yeah. Okay. So
yes. How many times does it say this? Apparent age with 100% certainty. It's called an apparent age because it's not the real age.
So because it says 0%, therefore it's wrong. So when the science says, wow, our data's good, you just say, no, it isn't. Plus, I'm not seeing an age range on here. You can be giving a range of dates and say that the certainty is, or that the uncertainty or whatever is 0% because it's within a range.
It's called an apparent age because they believe it's not the true age. and they're saying it's 100% certain
that it's
that
within
it's
that
not
range.
the true age.
Yeah.
Is basically how you could read this.
No, the uncertainty for this, it could very well be that we have 100% certainty that the age is within the range that we are giving. That's actually not that is not normal, or sorry, that is not abnormal in when you collect scientific data like this. The range can be, you look at those plots where it's like the vertical bar graphs with the lines or whatever. I don't know what they're called. But yeah, you can say we don't know 100% what it is, but we are 100% confident that its age falls within this zone. So does that say anywhere on there?
Do you know what 500, what percentage 500 is of 6,100?
What percent 500 is of that? Less than 10%?
6,100. Yeah, it's about 8%.
Okay. What's
8% of this data literally says it's not the real age.
8% is a small number. Have you ever looked at a normal distribution before? Like,
yes, but that also
a significant portion
tells me that none. That also tells me that none of these percent uncertainties can be less than 8%. If 8% of the time, minimum of 8, because some of this is actually the same basic conclusion but with different wording. You cannot have a number here greater than 8% if 8% of the data is not even a real age.
Says
that
you.
That percent uncertainty, do you know what?
Wow, that really, the one, so 4,100 out of, what was it, 6,200? How many total? I know it's not my turn to ask questions, but I'm just trying to clarify what data we're looking at.
Anchored discordia. You want to include those? Arithmetic mean, discordia, dispersed individuals. Every one of these that I've
photosynthesis. Are we just saying words?
Do you know? Do you know what those 15 anchored discordia?
No.
It means it's not the real date. It means they're plotting isochrons that are not the real date.
And so you're telling us that the scientists are publicly on public access publishing data that average Joes, well, you're smarter than the average Joe, but regular people can look at it and be like, wow, they're lying. Again, this is flat earth stuff. They say that the red thing on the NASA logo, oh, that's the snake's tongue because they're being deceptive because NASA is Hebrew for to deceive. Shit like that. Like what are we doing?
Eric, at what point did I say anybody was lying about the data?
Right there?
No, I did not.
Okay.
You did it again. You keep putting words in my mouth. I never said anybody was lying.
So are they incompetent?
Not one time.
So they're telling us it's not this old, but here's a study of us telling you how old things are by doing radiometric dating. That's completely dishonest. Would it not be?
They are literally telling you right here that they do not think this is the age. I did not say they were incompetent. I did not say they were lying. What I said was they have agreed a priori to use naturalistic means to try and measure age, but it does not work. That is all I said, Eric. I did not come up with any conspiracies. I did not accuse anybody of lying, and I did not accuse anybody of being incompetent. I said they have come to an agreement to use naturalistic means to try and measure dates that cannot be measured.
Okay, well, that is dishonesty because they're publishing a study saying we dated these things to this age. Oh, by the way, nobody actually can tell how old anything is. That would be completely dishonest. You don't have to call it lying, but you're accusing them of dishonesty.
What I'm accusing them of is trying to use naturalistic means to derive an age, but it cannot be done. That's it. It's that simple, Eric. It's not more complicated.
Thus saith you, not saith literally scientists. So I don't know.
So let me ask you a few more questions, maybe kind of rapid fire sort of thing.
Yeah.
If the Earth were 6,000 years, approximately 6,000 years old, would you expect to find carbon-14 in coal and diamonds?
Yeah, because contamination happens.
That's the only reason?
Yeah, there's also this weird phenomenon of like recrystallization with carbon. I don't know a lot about it, but I'm aware of it.
Do you know what the half-life of carbon-14 is?
5,730 years.
Is 5,730 years less than 6,000?
Yeah.
If the Earth were approximately 6,000 years old, how many half-life cycles could have possibly transpired for carbon-14?
Slightly more than one.
Barely more than one.
Yeah, that's what I said.
So would you not agree then that if the Earth were less than 6,000 years old, you could also find carbon-14 in coal and diamonds because it hasn't been there long enough to get rid of it?
I can't believe you're actually unironically doing this right now. You're doing the thing I said earlier where, oh, we find carbon-14 in bones. Well, and the amount of carbon-14 in the bones says that these bones are 40,000 years old. Therefore, the Earth is 6,000 years old. This is so silly. This thing about diamonds.
This is a cross-examination. It was a simple question. Would you agree?
And it has a
Would you agree that if the Earth were only 6,000 years old, that you should still find carbon-14 because it's only been
not trace amounts of the stuff. The amount of stuff we find in it is the equivalent of it undergoing 6, 7, 8 half-lives. Trace amounts are what we find. If it's only been barely over one half-life, then it should look like only one half-life has passed, but that's not what it looks like. We get these numbers in the tens of thousands of years, but after that many half-lives, you have less than 1% of the original radiocarbon, which is what the background noise looks like. You can have contamination in almost any sample. The thing with the diamonds, that paper, I can't believe you guys continue to lie about what that paper says, or maybe you haven't read the paper. They were measuring carbon, and they did it with graphite, or not carbon, sorry, diamonds and graphite to show, yeah, look, the instrument always records a microscopic amount of carbon-14. They got the same amount of carbon-14 in the diamond versus the graphite because the machine detects a small amount of background radiation of that carbon-14.
Are you done with your presentation so that we can continue my part of the cross-examination?
Oh, hell,
actually,
I'll keep going.
Let's do this because that was 30 minutes, but this is a good topic. It's an interesting topic. Why don't we now just smoothly transition into more of an open dialogue? So not so strict, not lawyer style. You guys just discuss the topic. Let's say we'll go maybe another 15 minutes or so, more free flowing. Go ahead, guys.
Sure. But let me ask this question and then you can kind of take the floor. It'll be quick.
Yeah, just pick up where you left off.
Do you know what factors affect the amount of the carbon ratio in the atmosphere?
Nuclear testing dramatically changed the amount of carbon-14. We've known for quite a while that you can't date things that are less than, it's like a couple hundred years old, because of the nuclear testing. I want to say there was one other thing, but I can't remember what it was.
There's actually several things. Desertification can affect the amount of the carbon ratios in the atmosphere. Mm-hmm. Solar storms can affect it. Mm-hmm. Ice ages can affect it. Do you know why?
Not off the top of my head. I mean, if you change atmospheric conditions, like whatever, the flow of material in and out of the atmosphere, then you're going to be
magnetic. I was just going to say magnetic fields can affect it, but the impact that desertification and ice ages have is very similar in that they basically wipe out the influence of a whole bunch of plant life
Right.
on the planet.
Because that's how it gets
and
introduced.
that directly impacts the carbon ratio.
Yeah, so they calibrate it with things that of known ages, like historical sites, and they use dendrochronology to back that up too. Those things converge; they agree with each other. So that's how we have reliable carbon dates for things.
To what age do you think that would be?
It only
reliable C14 dates. I mean,
it has like a theoretical limit of like 50,000 years or more, but it really is only, as I understand it, reliable to like 30,000 years or so. Because again, after 60,000 years ish, that is like 8 half-lives, and take 100 divided by 8 or divided by 2 8 times, and you have a really tiny percent of the original stuff left, and that's indistinguishable from background radiation.
Indistinguishable from background radiation?
Yeah.
Okay.
Yeah, like there's going to be there's carbon-14 all over the place. If I were to take this thing and put it in a mass spectrometer, they're probably going to find a tiny bit of carbon-14 in it because it's in the atmosphere.
It's in the atmosphere. Did you not know that you can mathematically eliminate background radiation?
By doing
because you can mathematically eliminate background radiation for carbon-14 signatures, it's not indistinguishable. In other words, in situ carbon-14 in a sample is not indistinguishable from background because you can mathematically eliminate background.
And how do they do that?
How would you do it? I don't know exactly how they do it, but how would you do it? You would basically go back to what you described earlier. You take a bunch of samples of known age, you plot the carbon years, you know, the difference between carbon years and true age. This goes back to that whole calibration curve thing. You plot the calibration or the carbon years against the known age. And then basically you mathematically, once you combine the data, you mathematically can eliminate what the influence was from background. It's actually just a simple matter of subtraction, but you don't strictly have to do that with things of known age because you know what the age is, and you don't care what the influence is necessarily, other than knowing that you're not contaminating the sample directly. So you can be content just to compare the carbon years and make an adjustment with samples of known age. But if you want to eliminate background radiation, you can do that with samples of known age just by subtracting it.
Forgive me if I'm wrong, but it sounds like you agree that carbon dating can work.
There is actually the funny little what's the word I'm looking for? It's a bit of a I don't know what the word I'm looking for here is, but it's kind of funny because you got to ask yourself, if I'm carbon dating something of known age, why do I need to carbon date it if I already know the age?
To see if the carbon dating method is reliable. Scientists have a vested interest in having accurate, reliable tools so that they can do science.
Okay. And if I carbon date something and the carbon years are different than the actual years, what does that tell you about the absolute accuracy of the carbon method?
It depends on how much you're off by. If you're off by 1%, then do we have a huge problem? I would say no.
1% over a 300-year timeline, or 1% over a 5,000-year timeline? What does that 1% even mean?
It doesn't matter. 1% is 1%. So like 1% of a billion is a big number, but you're still 99% correct. You can't just be scared of big numbers and say, oh, well, throw it out then. It's still just 1%.
No, Eric, the point is that if it's 1% off on a 300-year timeline, it might be 20% off on a 5,000-year timeline.
How do you arrive at that?
It's not linear. We've already discussed this in depth, in that the carbon ratios in the atmosphere are variable over time.
Yeah, and they know how to... Yes, and scientists intensively study this to see how to calibrate these things.
Well, I appreciate you making my point for me, because you're not really dating it. You're not really dating anything. You either know the date and you adjust calculations to match, or you don't know the date, but you know the calculations had to be adjusted for known dates anyway, but you just don't know how to adjust them because you don't actually know the age of it. You're seriously reinforcing my point that you cannot measure age like that.
You're not making a point. To say that a measuring tool can get you accurate results if you calibrate it, therefore it doesn't actually date anything, is a completely asinine thing to say. So just really, I just kind of want a simple answer here. Do you think that carbon dating does work in certain applied instances, or do you think it always fails?
I think that if you can tightly understand the exact circumstances around carbon dating, this is a known historical fact. If you very well understand all of the variables that influence the carbon age in a given era, then you could hypothetically, it would work to get something else that fits all the exact same criteria, carbon date it, and it would give you the same answer. But you're back to the circular problem. You already know it's from the same era and should obey all the exact same rules.
I have no idea if that was a yes or a no. I have no clue. Or was it a sometimes?
The answer is no, unless you already know the age of it.
Then the answer isn't no, because if I know the age of it, then I can test the radiometric dating, and if I look and I say, aha, I got the same number, or within 1%, then what you can do is you can be like, okay, well, I dated that piece of charcoal at this archaeological site, and we know that this happened 3,000 years ago. Boom, I got 3,000 years. Now let me date other charcoal within this area because it was a city or whatever. And it's like, oh my God, all of the numbers are within like 1% of each other, 5% of each other. Yet you can date the thing. Like the idea that you have to calibrate it somehow means that the dating method, therefore, isn't really a dating method. It's just such a silly thing to say.
What are you calibrating it to?
Something of known historical age, like an archaeological site, for example.
So how do you know the age of something historically?
There are multiple methods to that. You conceded that this does occur. Like people write shit down on stone walls. This was the reign of, I don't know, Ding Dong the Great or something like that.
You roboted really bad when you first started responding, so I didn't actually catch what you said, but you're still making my point. So the 6,000-year-old thing, somebody in the comments before the debate actually began, let me show you what they're. I'll just read it to you. What it is that they were basically asking for: credible, testable, positive evidence for an approximately 6,000-year-old Earth. Credible. What does credible mean to you? What does testable mean to you? What does positive mean to you? Those are all very subjective words. So somebody wants a very subjective idea as absolute proof of the age of the Earth. The credible evidence is the biblical written history, people who were actually there, not people who weren't there, not people who are measuring, counting isotopes and trying to apply some math to tell them what the age is. People who were there. It's kind of like this question I was going to ask you earlier. Are you wearing shoes? You don't have to answer the question. Don't care if you answer the question. Are you wearing shoes?
What?
Well, 6,000 years from now, if you had written a document that said, I was wearing shoes, by your logic, because you can't have any science or anything else, anybody who wants to can just say, oh, he was lying. He doesn't know what he's talking about. He was mistaken. It's not accurate history. The point is that you basically take this philosophical position that we can't trust ancient documents because we weren't there.
I never said that.
That's exactly what you said about the Bible.
It's not what I said. I said it does not vault to the highest standard of truth.
The highest standard of truth is write down what you say and be truthful about it.
That is such a unbelievable. Do not ever, if somebody calls you and they have an Indian accent, TRock, please hang up. You, like, that attitude is you're just asking yourself to be taken advantage of. That's the silliest thing ever. Like, if somebody writes it down, that's the highest standard of what truth is. You know how fraud is committed? You know how embezzlements are done? You know that eyewitness testimony is actually known to be the most unreliable form of evidence?
Yeah. The most unreliable.
No, it is. This is
to be kidding me.
Eyewitness testimony is the most unreliable form of evidence. This has been known for so long.
So a mathematical model is the most reliable, is what you're saying.
No, what I told you what is the most unreliable. I didn't tell you what the most reliable is.
And I'm asking you, are you saying that a mathematical model is the most reliable?
I don't know. I've never thought about this before. What is the most reliable method? I have no problem saying that there are multiple methods that are equally reliable.
The irony here is that the peer-reviewed science is both observation, recording, personal testimony, and mathematical models. That's what peer-reviewed journals are. And you're saying that the peer-reviewed scientists that publish, because they're literally using their own personal observation and testimony.
You equivocating scripture with scientific papers that are published within the scientific enterprise at a university or something is just
it's a simple logical,
I wish I could come up with a more creative word, because I already used asinine, but I think that might be the perfect word.
It's a simple logical deduction. Scientists have to be able to accurately testify about what they do. But you're telling us that eyewitness testimony is the most unreliable thing people can do.
Is the most unreliable form of evidence, yes.
But that's exactly what peer-reviewed science is.
No, it isn't.
No? So
no.
Scientists don't know what they actually personally did. And don't testify in the journal in the form of written documentation what they did for their experimentation.
First of all, there are typically teams of people working on something together. But like the idea that I saw a thing happen is the same thing as I rigorously went to a lab and did science and went through the peer review process where people check my methodologies. To equivocate those things, I'm not entertaining that any further.
So just so you're aware, because you kind of asked me several times, am I a conspiracy theorist and stuff like this? I was basically going to give you this in the intro. I'm not a conspiracy theorist. I take a very orthodox position on both biblical, quote unquote, interpretation, and I take a very orthodox position on physical, observable, testable science. So when you ask me these questions like, do I think that scientific method can tell us anything about the natural world? Of course I do. I consider myself very orthodox. What I'm pointing out is the limitation of trying to measure time by counting objects and applying rates. It can't be done. That is my big argument in this whole debate, is that you cannot measure time by counting objects and applying a rate to it. If you don't already know the amount of time. If you already know the amount of time, your only confirmation is that you did already observe it.
Okay. So Donnie, I mean, I would take that as a closing statement, basically. And we have been going for a good hour and 45 minutes, roughly. Can I give a quick closing statement, though?
Yeah, let's do... Let's consider that the end of our discussion. It was a comprehensive one, an hour and about 16 minutes or even more. And so I think more than enough time to discuss the relevant points. And so Eric, TRock, appreciate it. Lots of fun. I knew you guys would be best friends after this. So, okay, yeah, let's do closing statements. You know, let's say up to 5 minutes if you guys want it. And so, Eric, we'll give you the first closing statement. Go ahead.
Sure. So according to TRock's like epistemological framework or whatever, if an eyewitness was there to write it down, that's the highest standard of what is and is not true. So I would just like to present, is the light gonna, there we go. There's my closing statement.
For a second there, I thought you were going to hold that up for 5 minutes straight.
No.
10 seconds left. TRock, you could do the same thing. Okay, well, appreciate that. TRock, let's give you a couple minutes, I guess, if you had anything you wanted to say in terms of closing a closing statement. Sure. Then we'll get into these audience questions. We got quite a few of them.
So Eric's closing statement was very indicative of his, it's very representative of his entire argument. He inaccurately represented what I actually said. I did not say somebody writes it down, therefore it's the highest standard of evidence. What I said was, if somebody wrote it down and they were telling the truth, you were not telling the truth when you wrote that down. You were just giving an opinion. Two different things. But you did this during the debate as well. You basically kept running off on these tangents about conspiracy theories and me accusing me of accusing people of lying, which I did not do, accusing me of accusing people of being incompetent, which I did not do. Your entire argument was based around that. I come to these discussions to talk about the science. I know what data looks like. I know how to analyze data. I've been doing it for years. I have yet to this day, as many of these debates as I've done on SFT, I have yet to see any old earther or evolutionist bring a legitimate set of data to the discussion. Not once. Because as soon as you bring a set of data, the first thing we're going to do is we're going to analyze the data for what's provided and what's not provided that should be. So my challenge to the old earthers is, bring me some scientific data if you think you have a scientific argument. Graphs on a PowerPoint is not a data set. It's a rendering of some of the numbers in a possible data set, but it's not the data set. So that's what I'm looking for. That's my open challenge to the evolutionists or the old earthers, as it were. Bring me scientific data that you think makes your case. When somebody does that, we can have an actual scientific discussion. Meanwhile, age cannot be measured by counting objects and applying rates. Age is known by human observation and recording. The biblical position is officially that some people tell the truth and some people don't. People who were there for a particular event are in authority to know. People who were not there for that alleged event are not in a position to know. So we don't have a naturalistic way of calculating a 6,000-year-old Earth because it's not possible. Instead, we have an historical recording of the history of the Earth that helps us to piece the timeline back together and arrive very definitively at a 6,000-year timeline. So I will stop there and thank you.
TRock, thank you for your closing statement. Gentlemen, that wraps up our opening statements, a good lengthy discussion. We got the best of both worlds, some free flowing and also some cross-exam, a lot of cross-exam, and a short closing statement. So let's get into our audience questions and challenges for tonight. And so, okay, let's start here. What we'll do is what we usually do in the Q&A. Whoever the question's for gets the last word, and that way we can move along smoothly. TZ Gardner. First question is for you, Planet Peterson. How does Peterson know that the Pompeii historical account aligns with the radiometric dating based on Peterson's reasoning about believing the Bible? Go ahead.
I have no idea what this is supposed to mean. Like the Bible is recorded history, but Peterson doesn't believe in the Bible, therefore he can't claim that Pompeii happened. Pompeii is an archaeological site that we can go to today. Those do exist for the Bible. I don't think everything in the Bible is false. I think a huge number of things in it are false. But no, I have no idea what this person's supposed to mean. Whatever, like Garden of Eden, it doesn't exist anymore. So there's nothing we can do scientifically to try to confirm that. The like remains of whatever Israelite population walked out of Egypt, those don't exist. So we can't do anything to try to confirm that scientifically. Tower of Babel, it doesn't exist. So there's nothing we can do to confirm that scientifically. So I don't know what point they were trying to make there, but that's my answer.
Thank you. TRock, go ahead.
Okay, a couple things. First of all, remnants of what people believe it was the Tower of Babel does still exist. And so it does actually match up quite well with biblical historical recording. But it looks like the question, kind of behind the question, or what the question is implying, I think, is Peterson made the claim earlier that eyewitness accounts are the most unreliable forms of evidence. And we know that the alleged radiometric dating method, the potassium argon dating or whatever method is used, aligns with it based on personal testimony. In other words, written historical accounts. So, in other words, Eric, the scientist, happily accept historical written accounts when it suits.
When scientific data converges with it, which we have for Pompeii.
Okay, but you are missing the hierarchy of the dating methods here. The potassium argon date is basically referenced or calibrated to, even if it is without adjustment, it's confirmed against the written account, not the other way around. We're not confirming the written account against the argon dating.
Eric, you get the last word. Question was for you.
I said everything I wanted to say, and I don't want to like start redoing the debate we had earlier. So we'll just go to the next one.
All right. Appreciate it. Let's move to the next one. Glancing at the questions, we got a lot, but you're kind of in the hot seat, Planet Peterson. Most are kind of for you. So for those in the chat, if you want to throw a challenge to TRock, feel free to send it in. Nephilim Free, $20 super chat. Appreciate the support. And looks like it's more of a comment than a question, but Eric, we'll give you a chance to engage and respond to it. So Neff says, diamonds are used to check the accuracy of radiometric dating because they can't contain C14 if they are millions of years of age. Yet C14 has been found in diamonds several times, proving diamonds are only thousands of years old. Eric, what do you got to say to that?
I literally addressed this. I'm really mad at myself because I closed the tab, but I have the paper that discussed this. So I said, I don't know why people keep lying about this. And here's Nephilim Free, who I've talked to before, lying about it. They put diamonds, and here I have the paper. I have the paper right here. So I will show, I'm not going to read this, but I'll just show it so other people can go look at it later on their own time. Oh, my camera's frozen too. But there it is. Right there. Oh, what the heck?
I think your slides might be
Yeah, why are my slides frozen?
You had a permanent shocked face.
Yeah. Sorry. I'm taking way too much time. So, right here. Sorry. I shared the wrong tab.
No worries.
So, look at that, and then I'll shut up because I got to fix my camera, and I spent too much time on this. So, it's not what you think it is, Nephilim. You're completely wrong on this. Read the paper.
Okay, thank you. Eric, TRock, over to you. Any thoughts?
Is my audio still coming in good?
Yes. Yeah.
Okay, because you guys, especially Eric, was roboting real bad a little while ago. Okay, so I honestly, I can't confirm whether that was the exact same paper that I've read, and I don't know if you simply showed the abstract or had the entire paper, but I actually thoroughly read one of the papers that talks about this. And so I would greatly appreciate it if the old Earth community would quit accusing people of lying. I read the paper very thoroughly. Nobody's lying. It's called a difference of opinion. The technicians, not the scientists, the paper that I read, the scientists were attempting to establish diamonds as a zero C14 reference in order to develop a dating scheme in excess or into 6 digits of years. In other words, north of 100,000 years. That's what the study was all about. They were trying to determine if they could use diamonds in that manner, and they assumed that exactly what Nephilim says here, that diamonds cannot contain C14 due to their age. Okay, the end result was everybody was stumped. The technicians opined, not the scientists, the technicians opined that it must be from micro-contamination, not background. They did discuss background a little bit in the paper I read, but they actually opined that it must be from micro-contamination in the diamonds. But they opined, they did not do empirical evidence to establish such a thing. So what does that mean? Well, the implications are that if you go pick up a piece of wood from an archaeological dig site that is absorbent, contamination is the only thing you could expect out of it. But they happily date pieces of wood from an archaeological dig site without fear of considering contamination. But yet diamonds that have an extremely tight lattice structure, very difficult to contaminate. You could look at them under a microscope and perhaps see evidence of some sort of film or other thing that's on the surface of the diamond. They did no such thing in this study. You would be able to detect contamination on the surface of a diamond much easier than you could detect it in a biological sample that's absorbent. And it highlights what I've been saying all along. You cannot tell the age by counting isotopes.
Eric, you get the last word. Go ahead.
The paper that I pulled up, what they were doing was trying to establish that background noise. So they put diamonds and graphite in the thing, two completely different materials, and the machine read the same date for both of them, which is what tells us that it's that background noise. So,
okay, thank you, Planet Peterson. Okay, the next one comes in for TRock from Andrew Cumming. My question for TRock: do you know the difference between a best fit line and a linear regression plot regarding what he said about isochron plots?
Well, it's essentially best fit lines are just an approximation of the trend that the data moves towards, whereas linear regression plot is basically an attempt to extrapolate positions on a data set. But the problem here that Andrew is not acknowledging is that the age is not determined by linear regression. It's determined by the slope of a best fit line. It's completely irrelevant to the isochron argument.
Thank you, TRock. Eric, anything you want to add?
I'm not a math magician, so I don't really have anything of value to add, probably.
Okay, no worries. Let's move on to the next question. Looks like there's... we'll get this one first, actually. TZ Gardner for Peterson. Believing in billions of years, you have to assume uniformitarianism. How do you deal with evidences that limit time to under the billions of years paradigm?
I'm not aware of any evidences that do that. Uniformitarianism, that's a built-in assumption, but we have scientific tests and checks that show that, wow, yeah, the laws of physics are consistent over time. What's really hilarious is, we didn't get into this, but a creationist that thinks the universe is so finely tuned that if anything was off by a tiny microscopic bit, it would all just explode into chaos and matter couldn't form. And then they go around saying, yeah, the speed of light was different in the past. Yeah, the decay rate constant which is a constant, was different in the past. So the actual own goal is on the other side here. I said, believe you have to assume uniform. How do you deal with evidences that limit time? Yeah, there are no evidences that limit anything to under billions of years. We can see billions of light years, for example. Case closed. And again, in order to reconcile that, the creationist has to say, well, the entire universe was just created huge all at once. Any evidence for that? No, but I have to believe that. Otherwise, I'm wrong. So.
Okay. Thank you, Eric. TRock, over to you.
Okay, per the norm, Eric completely does not understand the evidence or the arguments or the position of young Earth creationists. I personally accept decay rates as being constant, Eric. I personally accept speed of light being constant. I'm not the only one that does this. But to the direct question here, I will give you an example and I will let you flounder around with your lack of understanding of physics and mathematics with the example that actually fits this question. How do you deal with evidences that limit time to under the billions of years paradigm? The Earth's magnetic field is decaying at an alarmingly fast rate. There has not been an alleged reversal for 780,000 years. The actual limit that is posed by Earth's declining magnetic field puts it at per my slide. I actually had this on my slides. About 10,000 years is a maximum age. The problem here is that the Earth's core is largely a very hot ball of what I'll call dirty iron. If it were pure iron, the magnetic field would last longer, but it's not. It's dirty, and heat destroys magnetism. So now I will let you flounder around with your attempt at explaining physics and how you can have a 10,000 year, how you can have a 4.55 billion year timeline with a magnetic field that is essentially defying physics to have lasted that long.
All right. Thank you, TRock. Peterson, you get the last word if you'd like it.
So what you're doing when you give this magnetic field example is you're saying, no, it can't be an oscillating trend. It just absolutely goes to zero eventually. The magnetic field will never weaken again. This thing about how we're losing the magnetic field strength, I've seen this before for years, and I don't understand it, because when you that's really all I want to say about that. It doesn't get you to 10,000 years. From what I've seen, they say, well, it's lost, a significant amount of its strength. It's around, well, I have a source here that's saying it loses about 6% per century. Well, then the Earth can't be 6,000 years old, because it just completely goes away before then. So your paradigm is debunked. So I don't understand this one, why people bring it up.
Okay, thank you, Eric. Next one here comes in from Stephen Tibbetts. Question for Planet Peterson. If you build a theory on the data, isn't it circular reasoning to then claim the data proves the theory? And when it doesn't, you update the theory.
If you build a theory on data, isn't that circular reasoning to then claim the data proves the theory? Nobody claims that, because again, I said this in my opening statement, individual pieces of data, like one piece of data, doesn't prove anything. But when we measure something like the rate at which objects fall on Earth, and we get 9.8 meters per second squared on average, then we know that we have an underlying mechanism there. Some natural law is operating that's constant. So it's not like to call that circular reasoning when you do data and the data converges on a single point, and we conclude, therefore, that we know something about the natural world. To call that circular reasoning is just to not understand science or reasoning.
Thank you, Eric. TRock, any thoughts?
So yeah, the answer to the question is yes, it is circular reasoning. We actually had an example in my PowerPoint slide of exactly why that is. The 4.55 billion year alleged age of the Earth came from a direct measurement of a lead-lead isochron decades ago. However, somebody decided to recheck the decay constants for radiogenic lead and determined that, well, okay, that same plot really means 4.48 billion years. Now, let me ask you this. What's the age of the Earth? Is it 4.55 or is it 4.48? Which one do you want it to be? You can't observe either one. And if the isochron method actually worked, why didn't it just give us the correct age the first time? And if it did, then why is the decay constant updated to give a different age? Circular reasoning is very obvious here.
Okay, thank you,
tough
TRock.
question, Eric.
Go ahead, Eric.
The second time we measured it, it was within 1% of the first time we measured it. Therefore, it's false. Next question.
All right, gentlemen, let's see what we got here. One God is now here for Planet Peterson. Do you believe the current assumed age of the Earth, as posited by Claire Cameron Patterson's meteorite studies, or some other method?
That data's good. That was the first time we were able to get a decent number from it. But rocks in the Canadian Shield and some rocks in Australia, I'm not sure what part of Australia, get us to. We don't have any rocks on Earth that are that old because of convection in the mantle, and the Earth would have been molten at its formation. So basically, nothing from that time would have survived. But solar systems are formed from the accretion of material around the protoplanetary disk. Asteroids are that. Not every single asteroid in the solar system has been captured by a planet. We get new ones, we date them. Those are the ages we come up with. But no, I mean, I referenced earlier, there was the creationist scientist. He has a data set of hundreds and hundreds and hundreds of meteorites, and within a microscopic standard deviation of less than 0.1, they all converge at 4.5 billion years. So it's not just Claire Patterson, it's all the other studies that have also been done.
Thank you, Eric. TRock, any thoughts?
Yeah, I think Eric's misrepresenting whatever data is available. I'd be happy to look at that data and we could talk about it at some point. But Eric, I seriously doubt anybody took hundreds and hundreds and hundreds of data points from those meteorites that 4.55 billion year age assignment came from, because they were from lunar rocks. It's not like they're out there for public access where people can just keep on crushing them up and taking more radiometric samples from them.
So conspiracy brain again. I didn't say that they took hundreds of samples from each meteorite. I said that there are hundreds of meteorites. How many samples do they take from each meteorite? I don't know. But even if it was only one, the fact that the hundreds of them converge, if radiometric dating doesn't work, then what you would expect is to always get crap data. But the data is within less than 1/10, or the standard deviation is less than 1/10 in this case. So that tells us that we have good data, not crap data.
Okay, thank you, Planet Peterson. Next one here comes in from Krishan, question for both. And so, Eric, let's start with you. That way, TRock, you can get the last word on this one. For both participants, how should I, as an individual, go about learning scientific facts?
You can read, I've read a lot of scientific papers. The National Institutes of Health is that they publish huge amounts of stuff. When I wrote my first book, that was the most common source I went to. Scientific papers aren't really all that fun to read. I get most of my reading from, I have a library over there. Just pop science books are great. There's lots of really great authors who make it fun. Or, YouTube is indispensable too. So
appreciate it. TRock, go ahead.
So step number one, start with observation. It's the only way anybody can know anything is by observing. Step number two, learn the difference between what can be observed and known and what is an opinion and what is a calculated quote unquote fact. Learn the difference between those two. You can calculate some things with accuracy, but you have to have a way of confirming your accuracy. And there's a difference between calculations that follow mathematical principles and actual testable, observable science. They're not necessarily the same thing. In other words, you can dream up mathematical models all day long. But in the vein of learning good science, start with observation, start with learning what can be known. For example, you cannot know how many specks of dust are in a crater on the opposite side of the moon. That's not a knowable thing. You can calculate it. You can make estimates. You can think your estimates are reasonable, but it's not something you can actually know. Also compare things like gravity, because the evolutionary side likes to do this quite a bit, or the old earthers like to do this quite a bit. They want to compare 4.55 billion year age assignments to how we understand gravity that we can't actually see, don't necessarily understand what it is or what causes it. The difference is you can interact directly with gravity yourself. You've probably done it before. You probably never floated off the planet because of gravity. You cannot interact directly with 4.55 billion years. All you can do is make calculations and say that that must be the historical truth. There is a vast difference between those two types of science. So once you learn how to separate those differences and limit yourself to the practical limitations of math and human capability, you're on your way to more established science.
All right, very good, gentlemen. Centurion 737, question for Planet. Does he believe all secular scientists are 100% correct and can never be wrong in their dating method?
No, obviously not. But the only way to demonstrate whether or not our scientific data is incorrect is to keep doing more science. So, like, to say that this is like a weak point for science literally makes no sense. You can't. Well, that's basically all I need to say about it.
All right, thank you. TRock, anything you want to add? Oh, is TRock TRock, am I coming through?
You guys both roboted real bad and the screens froze up.
Okay.
Oh, looks like you're back, but go ahead, TRock. Yeah, feel free to answer.
Okay, I'm turning my camera off just in case it helps with the lagging stuff. But to expect people like Eric to think that scientists are always 100% correct on that stuff. The real problem here, though, is that they literally treat opinions and updating history as a true scientific endeavor when it's not. There's only one history that's ever happened to the planet. Only one. It doesn't change because you come up with different data and come up with a different opinion, come up with a different mathematical model. It doesn't change. That's not how history and time work. And so, yes, they can be wrong. Yes, they are frequently wrong. Yes, they constantly update their timelines and even the order of operations or the order of events sometimes. Case in point would be like which evolved first, grass or dinosaurs. But there are many, many examples where timelines get changed. But it basically demonstrates very well that they basically conflate changing historical events with knowable, testable science, and they're not the same thing.
Appreciate it. Eric, you get the last word.
TRock, you said only one time in the history of ever has science ever changed. So what was the what were you talking about there? Unless it's a long story.
No, I only ever made general statements. I gave one specific example of how the order of events has been changed by people allegedly doing science by switching the order in which grass and dinosaurs evolved.
You said that's the only time that's...
It was originally... I didn't say that was the only time anything.
You said there's only one time in history that something's been... Whatever. It doesn't really matter. No, I don't know. I don't want to say anything else with regard to this, I don't think.
All right, no problem. Okay, we've got super chat here. Eastgate adoptionist, looks like it's for you, TRock. Is Genesis 1 and 2 symbolic for the creation of the relationship with God? Was Adam the first literal human or the first priest formed and placed in the garden relationship?
Well, the short answer is yes, Adam was the first literal human. He was literally intentionally created in the garden. Genesis 1 and 2 are a literal historical rendering of the events of creation, and they have symbolic meaning as well. It can be both. It's not a dichotomy. So there's my answer. The historical writings of Genesis are accurate, but they are also symbolic in some sense of the word, and Adam was the first human.
Okay, appreciate it. Eric, anything you want to add to that one?
I mean, I don't believe in the story, so I mean, I'm probably not the best person to ask, but like I think TRock just said the events are accurate, which is really funny considering light was created before the sun. That obviously makes no sense. So
TRock, you get the last word on this one. Go ahead.
Yeah, the light before the sun makes no sense to anybody who doesn't accept that God is the creator of the universe. Because if you fast forward in Revelations, you find out that once again in the future there will be no sun, but there will be light. In Revelations it tells us that God is the light of the city, and I would assume that in Genesis days 1 through 3 that either God was the light or he just created a temporary light without giving us the details. But it makes perfect sense in theism that this is the case. It only doesn't make sense to somebody who rejects God.
so we don't know, we assume.
All right, gentlemen.
The rest of it.
Here's our final one for tonight's Great Age of the Earth debate, made by Jim Bob, one of your biggest fans here, Planet Peterson. I think you guys go back a little bit. And so he's coming at you. Let's see what he's got. If the constants of decay could be different in other parts of space, and Earth is aggregate of foreign matter, does this impact dating methods?
If the constants of decay could be different in other parts of space and the Earth is an aggregate of foreign matter, does this impact dating methods? Not really, because even if the rates were different, the amount of energy that is expended by them is not different. So this is his thing here is a little bit different, but something creationists have proposed is that the decay rates were different in the past to make them look like what they are today, but that would release an amount of heat equivalent to like thermonuclear bombs going off every square kilometer or something like that. And you'd have the same problem with Earth being formed by an aggregate of materials. I mean, the Earth would be plasma and it wouldn't form this way. But even if we just say, sure, maybe in different parts of the universe, which it's our local neighborhood anyway. That's like saying the laws of physics are different on the moon versus Earth, but whatever. Sure, maybe it could be possible. Do you have any evidence of it? Because if you don't have any evidence of it, I don't really care. So that would be that's my answer.
Okay, appreciate it. TRock, over to you.
I appreciate the question, but let me be very clear about something. I know that there is a difference of opinion among young Earth creationists on the decay rates and the constancy of them. I personally, and I think I said this earlier, I do not agree with the idea of variable nuclear decay rates in radioactive elements. I know that like AIG endorses the idea. I know that other creationist organizations do endorse that idea. Personally, I do not. So I agree with Mr. Peterson on this regard that we don't even need to consider them. But does it impact the dating method? The reason it does impact the dating method is because of what I demonstrated in my slide, the open nature system of liquefied rock is that your isochrons are free to move around. And if you don't know the history over time, Eric, pay attention and learn some physics. You seem to be lacking in that department quite a bit. Pay attention. If you heat a substance up, you will get thermal density sorting out of it, which means that the lighter elements move to the top, the heavier elements move to the bottom, and they separate themselves by density in the presence of heat, specifically in a liquid medium where they have more freedom to move around. The longer or the older a liquid substance is, the more likely that is to happen. What that means is you will get some sort of trend where all of the samples you take from a given event happen to have very similar ratios, but it's called thermal density sorting. It's what happens. You can do this on your stovetop, put an experiment together of your own choosing, but you can take a liquid medium, you can put different density objects in it, heat it up, and watch the lighter objects move to the top. It's physics 101, Eric. One of the facts that is well understood by geophysicists, it's just not published in the literature where the age of the Earth is concerned, but you probably will find it in other types of literature that aren't concerned with the age of the Earth.
All right. Eric, you get the last word. Go ahead.
The idea that if there were fewer of those isotopes on the top versus the bottom is completely irrelevant, because what you do is measure the ratios of the parent material and daughter product. It doesn't matter. This is like when you carbon date something. It doesn't matter if you carbon date a kilogram of tissue or a gram of tissue. If it came from the same material, then in either case, those ratios would yield the same ratio. There's more in absolute terms over here, but the ratio will be the same as in the microscopic sample. And it doesn't matter if up here the rocks don't have a ton of lead, the ratio or uranium lead, whatever, that's irrelevant, because the ratio of the uranium lead to what's available there, where it's less dense, is going to be equal to the sample down there. So maybe you need to learn some basic physics.
Okay, gentlemen, that wraps up our Q&A and the debate itself. Very engaging, fast-paced, entertaining debate, Eric and TRock. So, okay, I appreciate you guys doing this. I appreciate the time to prep and also do the debate. Let's get some final words, final thoughts if we can. Planet Peterson, TRock, hope you guys had a good time. Eric, let's start with you. Final words, final thoughts.
I don't want to relitigate the content of the debate really all that much. TRock and I vigorously disagree, but he seems like a good guy and a cool dude. So thanks for doing this.
There we go. You're a cool guy and a good dude, TRock. I knew it. You guys would be good friends by the end of this. So this was fun. I enjoyed it. TRock, appreciate you doing this. Final words, final thoughts.
Yeah, I appreciate the discussion as well. No need to rehash anything at all. Some things I did appreciate about Eric's presentation is that he had a fairly thorough, comprehensive slide put together for the cross-examination. I do appreciate that he at least tried to focus at the data. I appreciate the fact that he was, by and large, not disrespectful altogether. So thank you for that. The things I did not appreciate was constant references to me accusing people of lying, constant references of me being a conspiracy theorist, constant references of me thinking scientists are either lying or incompetent. I did none of that stuff. And the only other thing I did not appreciate was the taking the Lord's name in vain. We don't do those things. If you don't believe that God exists, using his name to enforce your argument is completely meaningless at best. But other than that, I enjoyed the discussion. We can do it again sometime. Maybe the next time we get to do this, Eric, you can avoid the talk about conspiracy theories and lying and just focus on the data.